Hello everyone, welcome to Master the Codes, and today we are going to take another question related to Amazon interviews. And this is the best time to buy and sell stock. 2, because they usually ask this particular problem, they do not ask the previous version or the first version because it is quite simple. They tend to ask this particular problem and the higher versions of this, like you even have part 3 and part 4 for this particular question. So today we are going to discuss part 2. So let us see. You are given an integer array prices where prices of I is the price of a given stock. Okay. On each day you may decide to buy and sell the stock or sell the stock. This is the main thing. You can only hold at most one share of the stock at any time. However, you can buy it then immediately sell it on the same day. Find and return the maximum profit you can achieve. Okay. So let us try to first understand what this question says. Given this particular question, I am able to buy and sell on the same day. I can buy, hold the stock for a limited number of time for a given time, and then sell it on another day. Okay, now whenever I am buying, I'm spending money, and whenever I am selling, I'm gaining profit. So to gain the maximum profit, the selling should be always greater than buy. Otherwise, I will be at the loss, right? So the first thing that comes to mind is till when I can buy and sell. Of course, you can buy at this point and sell at this point. Second thing, you can buy at this and sell it itself, right? So in that case, it would be 3 minus 3 equals to 0. And if you're buying here and selling at here point, it would be 7 minus 3 equals to 4, right? Rather 3 minus 7 equals to negative 4 because you are selling, right? Here you are buying, right? So the thing is I can buy and sell till another day. Now, what are the operations that I can do? I can buy a stock and hold it for a limited amount of time or sell it not immediately but after t number of days. Like if you can see over here, I am purchasing stock on, let's say these are the days. I am purchasing stock on day 2 and selling at day 5, and I am purchasing stock on day 2 and selling at day 4. This is possible. So in this particular case, I will get a profit of 3, and in this particular case, I'll get a profit of 4. So there are 3 operations that I can do. I can either buy or hold or sell. Now, which particular operation I need to perform to gain the maximum profit? The first thing is I need to make sure the selling price should be greater than the buying price. Then only I'll be able to gain the profit, right? Also, if I'm buying, the profit will decrease by a given amount, right? Because you have money, you are spending it, so of course your profit is decreasing. But when you are selling, you are gaining money, so profit will increase by the amount of the share. So if you are, whatever be a profit, if you are buying, your profit will be decreasing, it will go down. But if you are selling, your profit will increase. So this calls for recursion. Now why we'll be using 2D DP, I'll tell you later, but first thing is what to do in terms of recursion. Looking at this, given a day, we can either buy, hold or sell. Also, one thing you want to note down, that we can buy and then only sell. Like we cannot sell an empty stock, right? We don't have anything. Also, you can hold only one stock at a time. So if you are buying, then you have to sell it to buy it again. I'm repeating, if you are buying, you have to sell it again to buy it. So I can use the recursion technique to check for buying. Increase the I counter and will decrease the profit by the given amount, or I will simply increase the I counter and do nothing, right? I'm just holding or skipping that particular day. In terms of selling, I'll increase the counter of I, move to the next day and increase the profit, or I'll increase the I pointer, move to the next day and do nothing. I'm holding. This time I'm not skipping, I'm rather holding. So I'm performing 4 operations: buying, selling, skipping and holding. right? And if I don't buy, then only I can buy, right? If I haven't bought before, so that means if I am buying stock 7 at this point of time, I cannot buy at 2 because I have already purchased one stock. Also, if I have bought, then only I can sell. If I have purchased stock at 7, then only I can sell it at 6. Or if I purchase stock at 2, then only I can sell it at 6. One thing. So these are the parameters that will work in your recursion. The I, the current pointer, n, the length of the array given, price is the array itself, and profit, the total profit you are gaining. And this particular thing will be for the buying and for selling, right? And since some states will be repeated, if you draw the recursion table of the entire tree, that would show you that some states are repeated. So in those particular states, the profit depends upon the index, right? The profit depends on particular day, on this particular day, and whether you have buyed on this day or not. If you are buying, then the stock will, or your profit will change, and if you are not buying, then your profit will be different, right? So if you're buying, your profit will be different, and if you're not buying, the profit will be different, and for each day it will be different. So basically your dynamic programming will depend on two parameters: the current day, that is your I, and whether you have bought any stock or not. So since you can see, you can put buy as a boolean variable. You can put buy as a boolean variable. So your DP will be a 2D DP, a 2D DP, where I would represent the length of the array, that would be a dimension n, and buy will be of dimension 2, that would be either a buy, you can put 0 as a buy or 1 as a sell, or vice versa, right? Also, you don't need to pass the profit as a DP, because in minimization or whenever you are performing DP with recursion, you do not need to pass the actual value that you are evaluating, because that could hinder the dynamic programming. You normally evaluate it, you will not pass it as a parameter. As you can see over here, I have earlier, when I was using recursion, I have given profit as a parameter. But if you are using DP, you will not do this. You will simply iterate over all these three values only. So that is for the logic. If you look at it, it would be order of n in terms of time complexity, and space complexity as well. It would be order of 2n. That would get reduced to order of n again. So now coming to the main file. And earlier we had solved the question 1. Now we're going to solve question 2. So now let's jump into it. So here is the code for it. And now I'll explain this particular, the dynamic programming case, because if you run this particular code, the profit helper function, it will work, but it will give you time limit exceeded in a particular test case, because it is simple recursion. So that is why I'm gonna tell you what is this particular function doing. So now let's jump into the algorithm written over here from scratch. So here in the question, as told previously, I will be passing I, n, the prices array, the buy index, and the DP matrix. Now this is the base case. If I equals to n, this is my base case that will terminate the recursion call. Now what I am doing over here in this particular line, I'm simply checking if buy is true. If buy is true, put it to 1, else put it to 0. Because I'm creating a 2D matrix, right? And I'm assigning 0 as buy and 1 as not buy. But in this particular 2D matrix, or in this particular array or table, you do not have values for boolean. So that is why you need to convert it into integer. Now if this DP is not evaluated as of yet, if the state is not evaluated, or if the state is computed, right, it is already computed, then you do not need to perform all these recursive calls. You will just end it at this particular point and give whatever the output you have received. Now these are the two options which you have. In the first option, you are going to the next, right? If you had these particular values, you are going to the next updating the value of n, keeping it same, setting is at true. Now this means you have buyed, right? This means you have bought the particular stock on ith day, and now you have moved to the next day, and subtracting the value of this from the profit. And what is the second option? I am moving to the next day, keeping it as false. That is means I am skipping the day. And this entire thing, this entire logic is happening when I have not purchased any stock or not bought any stock as of yet. Now, if I have bought, remember, if I have bought, then I can sell. Now, what are the options to sell? I will move to the next day, set the buy to false again. That means after selling, I can buy the stock again and increase the profit by the given amount. Or I'll simply move to the next day, keep the condition as true. That means I'm currently still buying that stock. I have not sold it, and skip the day. Now all these values, whether it would be option 1 or option 2, whichever gives me more profit, I'll store it according to the index. And when I have stored it according to the index, I return the value of dp of I. So that is for the code. Thank you everyone for watching. Please do not forget to like, share and comment, and subscribe to the channel for more notifications.